Alright, let's crush a Sudoku. This one's got a nice long rule set. I like these weird rules that make you figure some stuff out. So let's figure some stuff out. This one's called Zone or Killer by Clover. Normal Sudoku rules apply, so we're going to be looking for the digits 1 to 9 every row, every column, and every 3 by 3 box with no overlapping in the digits. And then we got these cages, and they're either a killer cage or a zone cage. I don't know if I've heard of a zone cage before. In killer cages, digits in the cage sum to the value indicated by the small clue in the corner of the cage. So these two numbers, if this was a killer cage, would have to sum to 19, which I'm noticing is impossible. So what's a zone cage? Because 19, the biggest number in a Sudoku is 9. So the biggest total we can make with 2 cells is 8 and 9, which is 17. So that's not going to work. So this zone cage must be coming into play there. In zone cages, the clue in the corner tells you some or all of the digits that appear in that cage. For instance, a clue of 23 would mean that the cage contains both a 2 and a 3. You'll have to decide which cages are which. Some or all. Okay, so this, since it's 19 and it can't be a killer cage, as I was just saying, this is going to be a 1 and a 9 in the cage. So the 19 is telling us that the digits are 1 and 9 because the digits can't total that. The same exact thing is happening here with this 19 cage. All right, so right off the bat, we're going to be able to put some stuff in. So not big numbers, but we got a little bit of info here. 77 is obviously way too big to be a killer cage. So that means that 7 and 7 have to go in this cage. 2 separate 7s, and the only way they can go in is in the corners here. So those are just straight up 7 and 7. Okay, so we got some big numbers in the puzzle already. So 14 you can make with 2 numbers. 12 you can make with 2 numbers. But neither of these can be 1. So if they weren't killer cages and they were zone cages, then the 1s would have to go here. We'll see what happens there. 24 is too big again, so this is a 2 and a 4. Oops. And then this is a 9. So this can't have a 9 in it. So these 3 numbers add a 9, which is limiting for sure, because 9 is a small sum for 3 digits. I guess it's not super limiting, but the biggest number we could possibly have would be a 6, but that would require a 1 and a 2. So, and since we have a 1 here, the biggest number we can have. Okay, so that is very low. Does this have to be 2, 3, 4? Yeah, it has to be 2, 3. Since we can't have a 1 in this cage, and the numbers have to add to 9, and I know that the numbers have to add to 9 because this can't be a zone cage because there's also a 9 right here. Interesting logic happening there. So this has to be 2, 3, 4. 17 cage, only way that's going to work as a killer cage is if this is 8, 9. Same with this one. So you got to think one of these. Oh, and these can't be. Wow. So these can't be 1, 7 cages. These can't be zone cages. So they have to be killer cages. So these are both 8, 9. That's interesting. And this can't be a 9 because there's a 9 here. So so we're getting digits, baby. We're getting digits, baby. Love to see that. 8 and a 9 here. This cage could be a 9. Oh, either way, it's a 9. That's just definitely a 9 because the sum of the cage is in a 1 cell cage. So whether this is a zone cage or a killer cage is telling us that it's a 9. Again, so this is the same as the 77 cage. This 55 cage has to be 2 5s. Don't know what that's going to be. All right, we have a 9 here, so that's going to set the values here as 1 and 9. Same with this. All right, it feels like we're making some progress. So 2, 4 is going to make this a 3. Oh, I hadn't looked at that. Okay, cool. So this is a 3. Now 3 can be taken out of this. Whoa, that was a new animation. That's 3 in the corner. Can I see what was that? Deet deet doot deet deet doot. I don't know what that means. Okay, but that's 3 in the corner. That's 3 in the spotlight. We like that. 3 disappears from there. So this is 34. This is gonna have to be a 3, 4 cage. 19. This is a 1, 9er again. Okay. 23 is gonna be 2, 3. 19 is going to be 1, 9er. So it's definitely some symmetry happening here. This is looking very similar to what was happening up here. So this 9, the same logic is going to apply where this is 2, 3, 4. And then we've got a 2, 3 looking here. So this is going to be a 4. This is going to be 2, 3. 12 cage. It would be nice if we could figure out if that was a zone cage, because then that would put a 9 here and a 1 here. I don't know if we can yet. Are these 15s going to be interesting? We have 7 looking here, 7 looking here. So I think that's going to force this 15 to be 9, 6, and I think that is going to fix some stuff. Okay, because there's only 2 ways to make 15, 9, 6, and 7, 8, and we can't use 7, 8 because of these 2 7s looking down at the cage. So this has to be 6, 9, and the 9 can't go here, so this is going to be the 6. This is going to be a 6. This is going to be a 9. This is going to be a 9. This is going to be a 1. This is going to be a 9. This is going to be a 1. This is going to be a 9. That's got to be pretty much it for 1s and 9s, I would think. It looks like 9s are totally done. 1s are not. So one of these has to be a 1. Make note of that. One of these has to be a 1. Still could be this if this was a 2. I think that's still possible. 13 cage, interesting. 14, 12. What do we got going on here? 14. How many different ways are there to make 14? 9, 5. So 3. No, there's only 2. 9, 5. Can't be 9, 5. Okay, so there's only one possibility for this if it's a 14. If it's a total of 14 cage, or it could be a 1, 4. I guess there's not really a way to tell if it's a 1, 4. Because this could be this could be a 4 and this could be a 1. That's still possible, right? So, but if it is a killer cage, 8, 6 still works. No, 6 doesn't work. So this is a 1, 4 cage. Oh, and that's fixed. Okay, so the only ways to make 14 are 9, 5, which it can't be because there's a 9 looking here, or 6, 8, and there's 2 6s looking up here, so it can't be 6, 8 either. So this is a 1 and a 4. There's a 1 here, so this is a 1. This is a 4. This is a 2. This is a 4. This cage is looking almost full. Is something similar going to happen with this 12 now? Probably not. I mean, there's okay, so there's 9s, 8s, and 7s looking at this 12. So this can't be. Yeah, there's no way, because you need you can't do 6. You can't do 6, 6 in this cage. And we have 9s, 8s, and 7s looking at it both cells. So we need a high number to make a 12, and there's none available. So this is going to have to be a 1, 2 cage, making this a 1, making this a 2. Okay, this is now a 1. One of these has to be a 1. One of these has to be a 1. If this was a 1, this would have to be a 3. I think that's possible. Put a 4 here. Yeah, looks okay. All right, so 3 numbers left in the row, 3 numbers left in the box here. Might as well figure out what those are, I guess. 1, 2, we need a 3, a 5, and a 6 in the row. This can't be a 3 because there's a 3 in the box. This can't be a 6. There's the 6 looking up. So nothing determined there yet. Okay, 1, 2, 3, 4. Obviously we need 5, 6, and then we need a 7 here. So these could be, all of these could be 5, 6, or 7. Look like. No, this can't be a 5. So this is a 5, 6, or 7. This is a 6 or 7. Okay. Not much help there, unfortunately. Almost done with the cages. Probably some Sudoku to be done at this point. We got a 4, 4. So one of these two has to be a 4. Just looking up here at 4s. Doesn't look all that good. Are all the ones done now? No, the middle box. Oh yeah, these. I forgot about these. Twos. We got 2, 2. So 2s and 4s are going there. Not a lot of 2s in the puzzle yet. 3s. I only see 1 3, I think. 4s I was just looking at. I didn't see much more there. 5s. Put a couple 5s in early, but okay, so 5 has to be in here. Oh, this is going to be a 5 then, because we have a 5 here, and one of these has to be a 5, so that leaves this square for a 5. In the column, now is that going to do any work over here? Kind of. One of these has to be a 5. That's probably it for 5s. We definitely had a lot of high numbers. Maybe 6, 7s, and 8s will do something for me. Not looking like it though. Yeah, not really at all, unfortunately. 7s. Are these the only 2 7s? Oh man. And these are the only 8s. Huh. Where do I go then? What else is going on here? Maybe this 13 cage has more information for me that I haven't juiced out of it yet. Okay, so how do you make 13? Feels like there's a lot of ways. 9 would go with 4. We can't have that. 8 would go with 5. We can't have that. 6 would go with 7, which is the only way to make 13 left. So this could be 6, 7, or 1, 3. And I think 1, 3 is still possible. I think this could be a 1, and this could be a 3. So, I mean, I guess I can pencil mark that, but it seems like kind of a waste of time. But, so this is 6, 7, or 1. And this is 3, 6, or 7. I don't know how helpful that is. But maybe it'll make something happen in the long run. I don't know. Okay. Not a ton of constraints otherwise. So 3 numbers left here. I mean, there's a 4th box. There's four numbers left in the column. Is that what it's going to come down to? So you got 1, 2. I'm seeing 3, 5. So 2, 3, 5, and 8. 2 and 3 are here. So this is either a 5 or an 8. I guess I'll mark that. 2, 3, 5, and 8. Not constraining this at all. We got 2 and 3 looking here. So this is either... This is a 5 or an 8. So, oh, that's going to place a digit, isn't it? Because then we're going to have a 5, 8 pair. So 2 and 3 are looking here. So this is either a 5 or an 8. Which means that 5 and 8 both have to go here and here. Which means this can't be a 5. Which means it's a 3. Ah, it doesn't do it here. But it does. It puts a 2 here, I think, in the column. That was the only number left in the column. Okay, and this is not a 3, but we still don't know what it is. Okay, that was helpful. That was a fruitful try there. How about here? 1, 2, 3, 4, 5. We need 6, 7, and 8. You got 7 and 8 looking here. This is a 6. Need 7 and 8 here. That is still undecided. What else? So these 3. So in this box we only have 2, 3, and 4 left. There's a 2 looking here, which puts a 2 here because this couldn't be a 2. So there's a 2 here. This is 3, 4. And I still don't know what it is. But it is paired off with this one. Okay. 3 numbers left here. All right, something's starting to happen here. 1, 2, and you got 3, 4, 5. 3, 4, 5. Wow, 3, 4, 5 is not doing anything. And there's a 4 in the box already here. And there's, yeah. Oh, there's a 3 looking here too. Perfect. So this is a 5. And then these are 3, 4. I don't think that's decided yet. All right, only 3 numbers left in this row because there's a pair here. So we got 1, 2, 3, 4, 5. Then we need 6, 7, 8. It seems like we're getting a lot of like consecutive numbers happening for some reason. 8, 8, 8's got to go here. These are 6 and 7. Which is interesting because we have this 6, 7 possibility here. I don't think that's decided yet, though. Ooh, it is. It can't be 6, 7. This can't be 6, 7 if this is 6, 7. I'll explain that in a second. So since this can only be 6 or 7, and this can only be 6 or 7, this can't possibly be 6 or 7, which makes it a 3, which makes this a 1, which is going to do a lot of stuff, I think. 4, 3, 4, 1. Oh, this is excellent. This is excellent. Yeah, that's what I'm talking about. This is now a 2. This is a 3. Okay, big there. 6, 7, 6, 7. That should place this value. I think it is a 2. It looks like, which is going to make this either a 6 or a 7. Does that tell me anything? This is either a 6 or a 7. I don't think that's doing anything, right? Because if this was a 5, then this could be either one. Yeah. Okay. Okay, only 3 numbers left in here. Obviously, 2 of them are 5 and 8. And we need a 7. There's a 7 looking down here, so yeah, these are 5, 8, or 7. There's a 5 here. So this is either 8 or 7. This is 5, 8, or 7. This is 5 or 8. I guess I can pencil them out. We only have 2 numbers left in the row. It must be 7 and 8, right? 7 and 8. This one is 5, 7, or 8. These 3 numbers, 3, 6, and 8. So 3 here, this has to be 3. These are 6 and 8. There's a 6 here, this is a 6. This is an 8. Okay. 1 number left in the row, in the column. 1, 2, 3, 4, 5, 6, 7. These 3, 1, 2, 3, 4. We need 5, 6, and 8. 5, 6, and 8. Really? Just not any help there? 5, 6, and 8. Alright, these are 5, 6, or 8. Only 1 number left here. This has to be a 5, 6, or an 8. At least there's a 6 looking at it, which makes a 5, 8 pair here. Some kind of wild logic in this one. It's cool. I don't really know, but that's going to force a 6 here. A lot of like interaction between the rows, columns, and boxes happening here in this puzzle. Alright, I don't know when this happened, but this can't be an 8. This is an 8. 2 numbers left here. We need a 5 and a 7. There's a 5 here. This is a 5, 7. What's this number? 2. Looks like a 2. This is a 6. This is a 7. This is a 6. This is a 6. This is a 5. This is a 7. This is a 4. Are we cracked? I think we might be cracked. What else we got to do here? 6, 3, 2, 8, 7, 5, 8, 3, 4, 3 and 5. 3 here, 5 here. This one is a 2. No, not a 2. 3? No. 7. And 4. That's the puzzle, baby. Thanks for watching. Catch you later.